Hello everyone, let's look at 8C, Factorial Notation. Before we introduce the Factorial Notation, let's review the counting principle, especially the product principle. Let's look at the first example. How many ways can 6 people be lined up by? You want to line up 6 people. You have to line up 6 people one by one. The first step, you want to line up the first person. Then the second person, and then the third person, and then the fourth, and then the fifth, until you finish the last person. So if I want to finish this task, I have to use AND between the first person and the second person, the second, the third. So I have to use AND to connect each step. Therefore, this is an application of the product principle. I will use 6 lines to show I will be finishing this task using 6 steps. Step 1, which means I need to line up the first person. How many people are there at the very beginning for me to line up? There are 6 people, which means there are 6 different ways to line up the first place. The second step, I need to fill up the second place using a person. But one person has been arranged here. So that means I still have another 5 people to choose for step 2. Step 3, after I arrange the second person, I still have 4 people left to line up. So the third place, which is the third step, there are 4 people for me to choose. And so on. So I should have 3 people to choose for the 4th place, 2 people to choose for the 5th place, 1 person to choose for the last step, which is the last place. Since I finished this task by steps, I multiply the number of ways in each step. 6 times 5, 30, times 4, 120, times 3, 360, times 2, 720, times 1, still 720. So there are 720 ways 6 people can be lined up by. Let's look at how we can solve the second one. How many permutations can be formed using all of the letters of the word compute? How many letters are there in total in this word? 1, 2, 3, 4, 5, 6, 7. And all 7 letters are different. If I want to use those 7 letters to form any word, that means I need to arrange the letters step by step. And until the last letter can be filled up. So I will have 1, 2, 3, 4, 5, 6, 7 steps to finish the task. For the first place, which is the first step, how many letters do I have to choose? 7 letters. After I fill up 1 letter in the first place, how many letters do I have? For the second step, 6 letters left. The same can be applied in the third step, which is the third place. So I still have 5 letters to choose. I still have 4 letters to choose, 3 letters to choose for this place, 2 letters to choose for the 6th step, and the 1 letter to choose for the last step. Since I finished this task by steps, I multiply all those numbers up. 6 times 5 times 4 times 3 times 2 times 1 is 720, which I have already got from the first example. I only need to use 720 to multiply by 7. The answer is 5040. Let's look at the last example. How many 3-letter permutations can be formed using the letters of the word compute? Very similar question to example 2. But this time, I'm not using all 7 letters. I only need to use 3 letters to form different permutations. 1, 2, 3. So I only need 3 letters. That means I only have 3 steps to finish the task. Let's look at how many ways do I have to finish the first step. There are 7 letters to choose. So for the first place, which is the first step, I should have 7 letters to choose. After I arranged one letter for this first place, I still have 6 letters left. So the second place, which is the second step, I still have 6 letters, 6 different ways to choose. The same idea for the next letter. I still have 5 ways to choose to fill up the third place. Based on the product law, I multiply those numbers. The answer is 210. Those 3 examples are the applications of the product principle. Let's look at what is a factorial symbol. Definition of a factorial. For n is greater than or equal to 1, and this symbol is called a factorial symbol. It's the product of the first n positive integers. Mathematically, n factorial is equal to n times n minus 1 times n minus 2 times n minus 3, all the way down to times 3 times 2 times 1. This n, the symbol is read n factorial. Let's look at how we can use this definition to calculate the following factorials. 1 factorial means I start with 1, ends in 1. So 1 just by itself, the answer is 1. 2 factorial, I start with 2, then decrease by 1 and end the multiplication in number 1. So the next one is 1. 2 times 1. That's the meaning for 2 factorial. The answer is just 2. 3 factorial means I start with 3, decrease by 1 all the way down to 1 for the product. 3 times 2 times 1 is 6. 4 factorial means start with 4, then times 3, then times 2, down to 1. 12 times 2, 24, times 1, 24. 5 factorial starts with 5, then times 4, then times 3, 2, until you finish the multiplication by number 1. 20, 60, 120, times 1, 120. 6 factorial means I start with 6, write down all the numbers in the product by decreasing by 1 all the way down to 1. 6 times 5 times 4 times 3 times 2 times 1. The answer is 720. What is n minus 1 factorial? N minus 1 factorial means I start with n minus 1, decrease by 1, n minus 2, decrease by 1, n minus 3. Since we don't have the concrete value on n, but I understand right now the concept for this factorial means I start with n and go down by 1 for the multiplication all the way to 1. So I just decrease every single number by 1 all the way down to 3 times 2 times 1. n factorial start with n, decrease by 1 by another 1 all the way to multiply by 3 times 2 times 1. And a note, n factorial equals n times n minus 1 factorial. Why? If you look at this n factorial, equals n times n minus 1 times n minus 2 all the way down to 3 to 1. This part is exactly the same as n minus 1 factorial. We also can derive n factorial can be equal to n times n minus 1, then times n minus 2 factorial. N factorial also can be equal to n times n minus 1, and then minus 2, then times n minus 3 factorial. You can keep the pattern going on. A very important supplementary definition for 0 factorial. 0 factorial we define as 1. So you need to remember this one. 0 factorial is not 0, it's 1. After we learned the factorial notation, we can revisit the first 3 examples. which was solved based on the product principle. 6 times 5 times 4 times 3 times 2 times 1. Right now, we do have a new notation, which can be used to represent this 720. 6 times 5 times 4 times 3 times 2 times 1 is the same as 6 factorial. Likewise, the second one is the same as 7 factorial. Example 3, 7 times 6 times 5, that's 210. I can represent this one as 7 factorial divided by 4 factorial. And I also can use graphing calculator to find the values of those factorials very easily. Let's look at how can I use graphing calculator to get 6 factorial. Let's turn on the calculator. If you want a factorial, the symbol can be found in math probability section. It's a function form. So if I want to put a 6 factorial in, I put a 6 in, then I go to math probability. I choose function form. 6 factorial, 720. Let's check the answer for 7 factorial. 7 factorial, math probability, function form, 5040. I also can check 7 times 6 times 5 using factorial notation. It's 7 factorial divided by 4 factorial, 210. Let's look at example 4. What integer is equal to? Each expression involving the factorial notation. Let's try now to use the graphing calculator first for the calculations. Of course, you can use your graphing calculator to check your answers. 4 factorial means you start the multiplication with 4, decrease by 1, all the way down to 1. It's 24. 5 factorial means 5 times 4 times 3 times 2 times 1. That's the numerator. 3 factorial in the denominator means start with 3 times 2 times 1. Then I can reduce the fraction by canceling the GCF between the numerator and the denominator. So the answer is 20. 7 factorial in the numerator means start with 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial means start with 4 times 3 times 2 times 1. 3 factorial means start with 3 times 2 times 1. Let's reduce the fraction to the lowest term. Those all can be cancelled out. 4 can be cancelled out. 6 can be cancelled out with 3 times 2. So the answer is 35 divided by 1, 35. Example 5, let's work backwards. Express a multiplication expression in factorial form. 10 times 9 times 8. Starts with 10, decrease by 1. But you don't have all the numbers in the multiplication to 1. I can do this way myself. So I can continue to multiply by 7, then 6, 5, 4, 2, 1, until I finish the multiplication to 1. Then I divide it by the factors I added on in the multiplication. But with all the numbers I added, I can write down the top as 1 factorial, which is 10 factorial. And the bottom should be 7 factorial. So 10 times 9 times 8 is 10 factorial divided by 7 factorial. The same idea can be applied in the more complex expression. 10 times 9 times 8, based on the first example, it's 10 factorial divided by 7 factorial. And the bottom, which is the denominator, start with 4 all the way down to 1. That's 4 factorial. Simplify to 1 fractional bar. So it's 10 factorial divided by 7 factorial times 4 factorial. Let's look at it, example 6. Write it as a product by factorizing. Let's look at 9 factorial plus 8 factorial plus 7 factorial. I want to write it as a product by factorizing. So I need to use a factorization to change this form to a product form. Let's think about the connection between 9 factorial and the 8 factorial and the 7 factorial. 9 factorial is the same as 9 times 8 times 7 factorial. 8 factorial equals 8 times 7 factorial plus 7 factorial. If I change 9 factorial and 8 factorial to these two expressions, I can discover the GCF in each term. So I can factor this trinomial by taking out the GCF. And for each term, I only have 9 times 8, then plus 8, then plus 1 left. Use the better math to calculate the value in the brackets. So we can have 72 plus 8, 80, plus 1, that's 81. The product by factorization for the first expression is 7 factorial times 81. Let's look at what can we do in the second one. Likewise, 10 factorial, 9 factorial, 8 factorial. Need to find the relationship among those 3 factorials. 10 factorial means 10 times 9 times 8 factorial. 9 factorial means 9 times 8 factorial plus 8 factorial. I can see a GCF in each term. Take out the GCF. Leave the remaining values in each term and evaluate the value in the pair of brackets. So that would be 90 minus 9 plus 1, 82. So the product by factorizing for this one is 8 factorial times 82. Let's simplify by factorizing. Based on what we have done in example 6, hope that you have more ideas for these two factorial symbols. 10 factorial means 10 times 9 times 8 factorial minus 8 factorial divided by 89. I can take out the GCF in the numerator. The GCF is 8 factorial. Let's factor out the 8 factorial. Then I have 90 minus 1 left in the brackets divided by 89. 90 minus 1 is 89. Cancel out with 89 in the bottom. So the answer for this expression is 8 factorial. The binomial coefficient. The binomial coefficient is defined by NR. This symbol also can be written as NCR. This is a combination symbol. Means from the N objects, I take out R objects and put them together. This symbol means N times N minus 1 times N minus 2 times N all the way to N minus R plus 2 times N minus R plus 1 divided by R times R minus 1, R minus 2 all the way down to 1. So this symbol also can be written as N factorial divided by R factorial times N minus R factorial. Some of you guys may have a question. You will ask how people derive this one from this notation. We will explain this notation in details in the combination lesson again. Let's just apply this formula to evaluate 7C3. Based on the formula, 7C3 means 7 factorial divided by R factorial, R is 3 factorial, times N minus R, 7 minus 3 factorial. This one will be 7 factorial divided by 3 factorial times 4 factorial. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial means 3 times 2 times 1. 4 factorial means 4 times 3 times 2 times 1. Reduce the fraction to the lowest term. It's 35. We also can use graphing calculator to find this NR or NCR value. Let's find C73. I need to put a 7 in first. Then go to math. It's still in the probability section. Function 3. Then put 3, which is the R value, in. Enter. 35. Let's calculate the next one, 11.7, which is the same as 11C7. Try not to use the graphing calculator to calculate this value. Based on the formula, it should be 11 factorial divided by 7 factorial times 11 minus 7, which is 4 factorial. You can write down 11 factorial as 11 times 10 times 9 times 8 all the way down to 1. But you also have another option. Based on example 6, example 5, I also can rewrite 11 factorial as 11 times 10 times 9 times 8, but start with 7 all the way down to 1. I write down the rest of the numbers in the multiplication as 7 factorial divided by 7 factorial times 4 factorial. 7 factorial, 7 factorial can be cancelled out. 4 factorial is 24. So 24 can reduced with 8 by 8. Then reduce the 3 with 9. Make this one 3, make this one 1. So finally the answer is 11 times 10 times 3, which is 330. Let's check the answer on our graphing calculator. 11, math, probability, function 3, R value 7, 330. Okay. The same calculation process can be applied to calculate 11.4. This is the same as 11C4. It's 11 factorial divided by 4 factorial times 7 factorial. If you compare this factorial notation with this 11.7, you will find these two fractions are exactly the same. This answer must be 330 as well. We can use the graphing calculator to justify this conclusion. 11, math, probability, function 3, 4, 330 again. Based on this calculation, we want to discover a relationship between B and C. And could you generalize this relationship? What is the relationship between B and C? 11.7 is equal to 11.4. What is the generalization? NR equals N minus R. R is 0, 1, 2, all the way to N. Those kind of whole numbers. N starts with 0, 1, 2, 3, positive integers, and a 0. This is the end of the lesson 8C.